right, ladies and gentlemen, we are going to start on 5.4. We're going to be factoring and solving polynomial equations. Our objectives are to solve polynomial equations other than quadratics. So we've done a lot of work with our quadratics, but now we're going to solve some higher degree polynomials. We're going to use a method called grouping. We're going to factor out a common term, and then we're going to use some of the methods that we previously used. So basically what I'm going to do today is do a bunch of different examples for you. And then maybe through that process then we can learn. So let's start our first one. And it's going to say factor completely. And actually they're all going to say factor completely. So I'm only going to write it one time. Your given problem is going to be x cubed plus 2x squared minus 15x. So the first thing that I notice is that these terms all have an x in common. So if I factor it out, I'm going to get x squared plus 2x minus 15. Now I can factor that inside piece. You could either do the AC method or you could do guess and test. I'm going to do guess and test. So I'm going to do x plus 5 and x minus 3. Okay. Notice that 5 minus 3 gives me the 2, and 5 times the negative 3 gives me my negative 15. My factors are all linear, meaning they all have a degree of 1, so there's nothing else that I can do. So this one is done. Yay! Alrighty. Okay, remember that the purpose of factoring is to solve. So just a note, if my original polynomial is a third degree, that means I'm going to have 3 x-intercepts, okay? And if you'll notice from our factors, I have 3. So x would be equal to 0, which comes from this one, a negative 5, and a positive 3. So factoring is a tool that we use to help us solve a polynomial. And by solving, I mean finding the x-intercepts. So one thing to remember, the number of intercepts is going to match my degree. All right, one example down, a few to go. So this one wants you to factor again. I'm going to have 2y to the 5th minus 18y to the 3rd. So if you'll notice, these guys all or both have a 2 in common and a y to the 3rd in common. If I factor that out, I'm going to get y to the 2nd minus 18 divided by 2 is 9, and y to the 3rd divided by y to the 3rd is just 1. Now I can keep factoring that. So this is going to be 2y to the 3rd, and then y plus 3, and y minus 3, because that's a difference of 2 squares. We started with a 5th degree polynomial. So now I have 1, 2, 3, 4, 5 zeros. So I would say that I have x is equal to 0, which comes from here, with a multiplicity of 3. Okay, and so that M stands for multiplicity, long word, which basically means that that 0 is repeated 3 times. We'll talk more about that later. And then I have, I guess I should say that y is equal to a negative 3 and a positive 3, so plus or minus 3. So there are my 1, 2, 3, 4, 5 zeros. Next example. So just a bunch of different examples today. If I have 4x to the 4th minus 16x cubed plus 16x squared, I want to take out what they all have in common. They all have in common a 4 and an x squared. Oops, I guess you can't see that, can you? Now you can. So if I take that out, 4 divided by 4 is 1. X to the 4th divided by x squared is x squared. 16 divided by 4 is going to leave 4. X to the 3rd divided by x squared leaves an x. 16 divided by 4 leaves a 4. And x squared divided by x squared is 1. And then if you'll remember, this is a perfect square trinomial. The square root of 4 is 2. The square root of this is x. Multiply together, I would get 2x times 2 I get the middle term, so I can rewrite this as 4x squared times x minus 2 quantity squared. So that tells me that I have x is equal to 0, which comes from here, with a multiplicity of 2, and x is equal to 2 with a multiplicity of 2. So I have 2 zeros, 2 2's, and 2 plus 2 is 4, which matches the degree of my original expression. When we're doing these problems, you want to make sure that you go as far as you can. You need to get down to a point when you can't factor anymore. So if I put my little box around this guy, that would be that one factored as far as it can go. All right. So now I have a new factoring method. I will always give you this formula because it is a little bit unusual to remember. So this is going to be a new factoring method. And if you'll remember, this actually showed up in your classwork yesterday. So what I'm going to do is what's called a sum or a difference of two cubes. Okay, and so I'm going to give you the formulas. So on a quiz or a test, I would give them to you. So a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And then if I had a difference of two cubes, I would get a minus b, a squared plus ab plus b squared. So that you don't have to remember those, I will give them to you. Your job will be to know how to use them. So let's do a couple of examples with these. So the first one is going to be factor completely. And this is what you're going to be given, 8x cubed plus 27. So notice that the cube root of 8 is going to be 2, and the cube root of x cubed is x, and then my b, the cube root of 27, is 3. If you don't happen to know that, you could do 27 in your calculator and raise it to the 1 divided by 3 power. And then that would tell you that it's 3, and that would tell you that this is the third root of 27. Okay? So if you don't know what the third root is, you can actually use your grapher to find it. It is very important that you put your exponent in parentheses on many of the calculators, not all, but in many. Okay? All right, so now I know this information, so I can actually use my formula. And I'm going to do the sum of 2. So notice that my first thing says it's a plus b. So my first factor is going to be 2x plus 3. And then I'm going to square the first term. So I'm going to put it in parentheses, and then we'll go back and finish it. Minus my ab times my b. There we go. And then plus my b squared. So all I did was once I found my cube roots, I substituted those values into this formula. So when you're doing your homework, I would recommend that you write that formula at the top of your page so that you have that for easy reference. But on a quiz or test, I'll give it to you. I now just need to simplify that piece. So this is going to be 2x plus 3, and I'm going to end up with 4x squared minus 6x plus 9. And then this would be the factors of that particular answer. So if I wanted to find my zeros, I could solve this, and I could do the quadratic formula on that, or potentially do the quadratic program that I haven't given to you yet, but I will show you how to use that eventually. So let's do another example. So let's say I have 64x cubed minus 1, and I want to factor it completely. You first need to find out what a is. The cube root of 64 is going to be 4, and the cube root of x cubed is x. Again, if you didn't know that, you could have done 64 caret 1 divided by 3, take the third root, and it would tell you that the cube root of 64 is 4. My b, the cube root of 1 is 1, because I can multiply a bunch of 1's together, and I'm still going to get a 1. Now I'm going to substitute it, and you can't see it, so hopefully you have this written down. I think I can squeeze it in right here so you can see the formula and then see how we're doing the math. So I'm going to substitute everything in. My a is 4x, my b is 1. Then I'm going to use parentheses again. I'm going to square my 4x, and then I'm going to multiply 4x times 1, and then I'm going to add 1 squared. Now I just need to simplify that expression. So this is going to be 4x minus 1 times 16x squared plus 4x plus 1. And that would be my answer of a cube. Alrighty? Okay, so now let's do another method. So 2 new methods today. This one's called grouping, and it's a little bit different than the AC method, but the result is going to kind of lead to the AC method. So let's say I told you to factor completely x cubed minus 3x squared minus 16x and plus 48. So it's not something, I can't take an x out because there's not an x common in all terms, but I could do some math if I grouped those two sets of terms together. So if I look at just the first two terms, they have an x squared in common, and when I factor it out, I would get x minus 3. In these two terms, they have a 16 in common. So if I factor the 16 out and I take out the negative, I'm going to get x minus 3. Well, now it looks like the AC method that we've done in the past. This term and this term both have an x minus 3 in common. I'm going to factor that out, and what's left over is x squared minus 16. This is a difference of 2 squares, so I can finish my factoring by x minus 3, x plus 4, and x minus 4. So that would be my answer. I had a third degree polynomial, and I got 1, 2, 3 zeros. And so I would have x is equal to 3 and then plus or minus 4. Okay? So that is a way to manage the method called grouping. All right. So I have a couple more examples for you. The next one. Okay. I'm going to have 16x to the 4th minus 625. So this doesn't really look like many of the other ones that we've done, but actually it does. The square root of 16 is 4, and the square root of x to the 4th is x squared. The square root of 625 is going to be 25. So this is going to be a difference of 2 squares, 4x squared minus 25. Okay, so it's actually a difference of 2 squares, but the variable is just a little bit weird. This one's done because it has a plus sign in the middle. This one, on the other hand, is another difference of 2 squares. So I could factor this one. I'm just going to leave the 4x squared plus 25. This is going to be 2x plus 5 and 2x minus 5. And now I have it in a form where it doesn't factor anymore, because if I have two terms and a plus sign in the middle, this one doesn't factor, but I would have 1, 2, 3, 4 zeros if I wanted you to find the rest of the zeros. Okay? Next example is another example of grouping. Okay? You're going to have 2x to the 8th plus 10x to the 5th plus 12x squared. Notice that all of those guys have a 2 in common. They also have an x squared in common. So I'm going to take that out first. X to the 8th divided by x squared is going to be x to the 6th. Okay. X to the 5th divided by x squared is going to be 5x to the 3rd. And then 12 divided by 2 is 6, and x squared divided by x squared is 1. This looks pretty weird, but this is actually still factorable. So I'm just going to show you how that would work. I'm going to write my 2x squared, and then I'm going to do 2 parentheses. I'm kind of going to do a guess and test. Okay, so x to the 3rd times x to the 3rd, remember if the bases are the same and it's multiplied, I add the exponents at the top. So that would be the 6. Then I'm going to add the factors of 6 that add to give me 5. So I'm going to add a plus 3 and a plus 2. And now let's check the work that we've done. X cubed and x cubed is x to the 6th. 2x cubed plus 3x cubed is 5x cubed, and 3 times 2 is 6. So now this one's done. And you might ask, why am I not factoring these two? Aren't they a sum of two cubes? But actually they're not, because 3 is not a perfect cube and neither is 2. And you could check that in your grapher if you needed to. All right, I have one more example, and then I'm going to give you your problems. So the next example says something slightly different. It says to factor completely and find the solutions. And remember that my number of solutions has to match the degree of the equation. Whoa, there it goes. Now it's in focus. So I'm going to be given 3x to the 5th plus 15x is equal to 18x cubed. Well, that's yucky. That's in a bad format, so I'm going to rewrite it and put it in standard form. This is going to be 3x to the 5th minus 18x cubed plus 15x equals 0. Now it looks much better. Notice that they all have a 3 in common, and they all have an x in common, so I'm going to factor that out. 3x to the 5th divided by 3x is going to be x to the 4th. 18 divided by 3 is a negative 6. X to the 3rd divided by x is x squared. 15 divided by 3 is 5, and x divided by x is 1. Okay? This is going to be one of my solutions, so I'm going to leave it out front. Remember that I need to have 5 solutions. That's my task, is to find all of those. Okay? So I'm just going to stick that off on the side. This is actually the same type of problem that we did earlier. X to the 4th could be written as x squared. The factors of 5 that give me 6 or 5 and 1, so I could do a minus 5 and a minus 1. Okay? Alrighty. And so if I check my math, x squared and x squared is x to the 4th. A negative 5 and a negative 1 is a negative 6, and a negative is a positive. Alright. These are both actually a difference of 2 squares, but the numbers are just kind of weird. They're not pretty, but I could do my math a couple of different ways. So I'm going to show you both. I could rewrite this as x plus radical 5, x minus radical 5, and x plus 1 and x minus 1. Okay? And that would tell me that x is equal to 0, plus or minus radical 5, and plus or minus 1. There are 1, 2, 3, 4, 5 solutions. So now let me show it to you a slightly different way, and I'm going to go back a step to the x squared minus 5 and the x squared minus 1. I can actually solve for x in both of these by setting them equal to 0. Minus 5 is equal to 0, so x squared would equal 5. Take the square root of both sides, and x would equal plus or minus radical 5. Do the same thing with this one. X squared minus 1 is 0. X squared is equal to 1. Take the square root of both sides, and I would get x is equal to, oops, that needs to go away, plus or minus 1. So I got the same answers. It just looks weird because 5 is not a perfect square. Alrighty, now let me give you your problems. And then you're done, you lucky dogs. Alright, here are your problems. They all say factor completely and find the solutions. And remember, your number of solutions should match the degree of the problem. Number 1, x cubed minus 7x squared plus 10x equals 0. Number 2, that's a cubed by the way, x cubed plus 7x squared minus 9x minus 63 equals 0. Number 3, 4x to the 5th minus 40x cubed plus 36x is equal to 0. Let me put 4 up here, number 4. I have 2x to the 5th plus 24x is equal to 14x cubed. Remember to put that one in standard form before you start. And then your last problem, I have a negative 27x cubed plus 15x squared is equal to a negative 6x to the 4th. And remember to put that one in standard form again before you start. Alrighty, there is your lecture for the day. I will see you tomorrow.